Okay, today we will look at our new topic. This is the final topic. Mismatch. Burger. Burger. Sausage telur ke? Sausage. Cakap nanti lah. Cuba tengok kat mismatch. Ada. Okay, kita tunggu kawan-kawan masuk lah. Okay, so I think ramai dah masuk. Tunggu ni. Okay, today we will move to chapter 5. This is the final chapter. About the reactive power control. So we have, for this course, we have learned about economic dispatch. This is a power store operation. And then we have learned about LFC, okay, low frequency control, ataupun nama dia real power control. And now we move to the voltage control, okay, ataupun reactive power control. So as I said previously, because we can control the real and reactive power separately, so normally real power more sensitive to the frequency, so that's why we control the real power separate with the reactive power, because reactive power and normally is more sensitive to the voltage. Okay, so power utilities are required to generate both real and reactive power, so this is we know already. While active power is energy supplied to run a motor, heat a home, or eliminate the electric light bulbs, the reactive power is used to provide the voltage level necessary for active power to do the useful works. So basically, the reactive power ni dia more related to the voltage sensitivity, because of even though dia adalah imaginary punya value kan, so that's why you punya S, remember you punya S equals to P plus JQ, right? So your Q is J. Okay, so reactive power is required to excite the various type of electrical equipment to energize the transmission system, and the reactive power compensation of the transmission system depends on the load and its power factor. So remember you belajar to improve the power factor, right? So apa yang perlu you buat ialah you inject the reactive elements. Biasanya you inject capacitor. Kan? So that's why you need to find the suitable capacitor punya value in order to improve you punya power factor. Okay. So initial RRP is to fix the power factor and then to supply quality service to consumers reliably and economically. The voltage or valve control is crucial at all levels. So basically, part of this topic basically you have learned in EPS. So yang ni more to extension lah. So to maintain nominal voltage at the receiving end, the system there's need to avoid over voltage. So we need to avoid the over voltage where your reactive absorption is more than reactive requirement. So what happen is when we have over voltage is like tiba-tiba you ada apa ni your load is decreased suddenly, so suddenly you punya voltage akan jadi over voltage. Okay, and then the low voltage where your reactive generation is less than reactive requirement, so suddenly you have a heavy loading, so you have a drop in the voltage. Okay, so that's why sometimes you need to do the necessary actions to make sure that your voltage normally maintained at the nominal voltage lah. So inject reactive power into the system, we raise the voltage, and absorbing reactive power lower voltage. So effects of the low voltage, what happened to the low voltage? Basically low voltage, as I said previously, is associated with the heavy loading on generators, heavy reactive loading. Dia ada orang angkat tangan ni, kenapa? Ada soalan? Kenapa dia angkat tangan? Okay, so tak ada, kita proceed lah. It causes poor performance in induction motor, so it is also responsible for higher stator and auto current. So that is the effects of the low voltage. And what happens if we have over voltage? So over voltage may occur due to any of the following disconnection. Suddenly your load is disconnected. So that's why sometimes you punya system already over voltage. And then we have line switching operation or lightning. So ini kita tidak boleh elak lah. So that's why you have this sepatutnya after you learn about this topic or this course, you learn about the protection of, okay. And then forensic effects for the long transmission line, which when the open circuit was lightly loaded, the voltage rise occurred at the receiving end. This one is the effects of the forensic. So what happens when we have over voltage? We have a breakdown of insulation, and we have saturation of transformer that lead to the high harmonic currents. Okay, so when it prolong terlalu lama, so menyebabkan sistem kita breakdown lah, ataupun punya lifelong apa ni jangka hayat transformer tu akan lebih kurang. So this one is the rated, the class of voltage. Okay, that I think this one is a common ni adalah common lah, seperti yang kita tahu. So we have a extra high voltage. This is the rated lah, about more than 400 400 kV. So we have a highest permissible voltage 420. Normally it's plus minus 10%, atau plus minus max I think 15%. Okay, and then this is the lowest voltage, permissible voltage. And then we have the transmission system from 220 to 110 kV. So this is the highest permissible voltage, and this is the lowest. Meaning that we want to maintain our voltage at the rated. And we have a start transmission, so we have 66 kV until 22 kV, and then we have distribution less than 11 kV. So this is the rated ataupun punya plus minus yang boleh accept. The system can be accepted. Okay, this is the typical power system operation ataupun what we have in our power system component that I think we have covered in the introduction of this course. So we have the generator system, and then we have a tap changing transformer to step up the voltage value. Okay, so this normally our generator produce low voltage, and then we step up by using the tap changing transformer. And then we have this one in terms of at the receiving substation. So we have a series capacitor, we have shunt capacitor. This is the reactive element to control the voltage level. And we have also, again, we have another step up or step down transformer. And then this is the distribution system. Okay, this is just a simple multiple power system components. Okay, generation and absorption of reactive power. So what happened? What is the generation of the reactive power? Mainly is generated by generators lah, generator itself. Because generators can generate or absorb. That's why when you learn about the power system analysis, when you do load flow, sometimes your generator can have a negative value of reactive power. Remember, if you learn the load flow, sometimes normally slack bus lah akan ada negative value kan. Maknanya when he has negative value, it means that in the system is have extra reactive elements ataupun reactive values. So apa yang perlu buat ialah you can absorb. So that's why negative will be absorbed by the generator. Generator can be made and absorbed. Okay, and then transmission line, light loads, synchronous condenser, cables, and so on and so forth. Okay, and then reactive power also mainly absorbed by loads, transmission line, and transformer. So this is the this one is loss, right? I square when fully loaded. Okay, let's take a look at the relation between voltage and power. So this one I think you have familiar. We have because you have learned in the model of the transmission system in EPS. Okay, so normally we have sending end. So we have a bus 1 and bus 2. This is bus 1. This is a sending end bus. This is a receiving bus. So and then we have the transmission line here. Your R and X. So Z is equal to RL, and L is not load, it's a line. RL plus JXL. So we have our voltage V1, magnitude and angle. We have voltage at 2, receiving end. So from here we can see you can use a simple circuit, okay, by referring to our simple circuit. Okay, plus minus is your V2, then here plus minus is your V1. So basically when the current flow, you have the voltage drop here, right? VD here. Okay, so when the current flow, you have voltage drop because this is a passive elements. So you can see here that we can derive V2 equals to, ataupun you boleh buat loop belajar dulu kan, V1 minus VD minus V2 equals to 0. Okay, so V2 jadikan tajuk, you dapat V1 minus VD. V1 minus VD is this one. V1 minus VD, where your VD is I times Z. So that's why you dapat V1 minus IZ. And also we remember that our S equals to P plus JQ, right? S equals to P plus JQ. Sorry saya tak ada pad ni, saya kena travel. Okay. So and then you know that VI conjugate, and it's also VI S also is equals to VI conjugate. So you boleh rephrase balik this equation and jadikan I tajuk, get I equals to P minus JQ divided by V conjugate. Since V1 is our reference, normally conjugate pun tidak masalah. So you can dapat P minus JQ divided by V1. Okay, since the V1 is the reference spacer, plus kosong. And from this equation, you masuk balik this equation into this equation. Gantikan, you akan dapat VI minus P minus JQ divided by VI dot Z. Since normally when we learn about the power system, normally the X ratio to R is larger, much larger. Normally we assume that our R is almost 0 lah. So you just jadikan dia kosong, you just masukkan, you dapat, we neglect the line resistance, you get the V1 minus JP over 1, V1 XL minus Q, V1 XL. So this is the relationship between the voltage power and reactive power. Okay, so when we do the phasor representation, we boleh buat phasor representation. Okay, so where your V1 is your reference. So what happened to V2? This is your V2. So you have the theta here, the angle. You can see that it is equals to V2 equals to, so V2 equals to V1 plus, or when it going down is negative lah. Kalau dekat atas dia akan tambah. Like phasor, right? So minus minus. So you can see here, you can already observe that look, the voltage V2 is not affected much due to the real component of the P, as is normal to the vector V1, and the drop dQ is directly subtracted from voltage V1, and then we assume that due to the voltage drop, okay, due to the voltage drop P equals to 0. So we rearrange this equation, dibuang yang ada P ya. So kita assume voltage drop to the P 0, dan tinggal elemen Q saja. So we get V2 equals to V1 minus Q divided by V1 XL. XL is your line, your impedance. Okay. So to keep the receiving end voltage V2 fixed, the particular sending end voltage V1, the QX must be remain constant. So what we can do here, we can adjust the Q to keep the quantity fixed by connecting shunt capacitor or sequence capacitor, or we can make sure that our QXL can be kept constant by introducing the series capacitor, which reduce the net reactance of the system, and voltage variation with more larger loads could be controlled by switching in suitable series capacitor. Okay, that is the relation between voltage, power, and reactive power. Okay, now let's take a look at the power transport and reactive power. So what happened in terms of power? Just now we want to look at the relation between voltage, power, and reactive power. So we look at similar figures, but here we have our, in terms of power transfer. So kita ada S, A is your sending end voltage power, SB is assumed that is a receiving power. Okay, and we have also I with the phasor here, and in terms of Z with the theta. So from here, basically similar derivation you can use. So SA equals to EI conjugate. So dimasukkan I conjugate is equals to, sama dengan equation tadi, E minus V divided by Z, can get your current. And your current is conjugate. And then you can, because your Z, E we have the reference theta, and Z we have theta. So yang ni you boleh keluarkan Z, because your Z is what? Your Z is the just constant. This is magnitude, right? So you keluarkan Z, disusun balik dalam ni. So apa yang ada ialah E, the angle of theta divided by Z. Here is E. And remember, when we have we have phasor, kalau kita buat division akan ada tolak kan. So that's why dapat theta minus theta. Theta minus theta. Okay. Untuk E kan. Tapi you kena ingat dia conjugate, so that's why dia balik lah. Ni ada kurungan lah. Jangan silap ada kurungan. Theta minus theta. Because we buang conjugate ni, and then kosong minus theta dapat negatif theta kan. So bila kita conjugate kan dapat positif lah. So that's why the equation is like this. Ni ada kurungan lah, jangan lupa. From here kita boleh boleh kembangkan lah. Where here theta bila didarab ni, E darab ni, yang theta ni boleh darabkan kan. Ditambah lah. Theta dengan minus theta akan negatif, akan cancel. So that's why dapat E over Z, and then theta darab akan ditambah. So dapat E over Z E theta minus V theta plus theta. Ni ialah ada kurungan. Silap. And then what you can do ialah kita boleh pecahkan lah. Kita boleh kembangkan, you do the expansion. E square over Z theta minus E V over Z theta plus theta. And then here what we can do is we applying a Euler concept. So from here we can apply Euler concept. You kena refer balik. Kalau tak ada Google lah. Google what is Euler. Double apa ni magnitude ni kita boleh tukar dia jadi cos and plus sin theta. So yang ini this component E square over Z cos theta plus J sin theta minus ini EV over Z cos theta plus J sin theta plus theta. Dan yang ini apa yang perlu you buat ialah you kena kembangkan and then you arrange balik lah. So E over square, so you kena kembangkan and you rearrange. And remember yang that's why dalam dia punya apa ni soalan final ataupun sebenarnya soalan test 2 lah. Sebab saya tak ada test 2 kan. So soalan final biasa you ada cara nak kembangkan kan. Cos A plus B tu ingat tak? Kita belajar dekat sekolah tu. So kita dapat cos A, cos B, sin A, sin B tu. Kan dia nak kembangkan ni. So you kena buat lah, cuba buat. Jadi kembang and then you boleh susun balik. You rearrange the equation. And then you boleh kumpulkan the real components and reactive components. So real components is your P, reactive component is your Q. Okay. So boleh kata yang ini ialah real component because there is no, kita kumpulkan cos and then sin ialah reactive component. So itu ialah P dengan Q. This one for the sending end power. Similarly, when we look at the receiving end, so we have a receiving end power, SB. So you boleh buat sama, dia VI conjugate. So you rearrange balik, you akan dapat PB plus JQB. Again, we assume that our R is 0. So and then when we have R0, normally when we have R0, you can have your X tukar dia dalam bentuk magnitude, angle, you can dapat because it's J. The real element is kosong. Normally your Jx become X, the angle is 90 degrees. So masuk balik dalam this equation, these two components equation, akhirnya you akan dapat this equation lah. You dapat PA EV over X sin theta, QA E square over X minus EV over X cos theta, PB sama EV bagi X sin theta, and QB dia terbalik kan, dia lain sikit, dia cos theta, EV cos theta minus V square over X. So this equation. Boleh kelas? Boleh. So yang ni you kena cuba analyze satu-satu lah. Okay, and then you look at example. So ni contoh lah. So we just quick example. So we have interconnected transfer P 60 megawatts between 2132 kV, three-phase power system having the same frequency. Assume that the interconnector is 100 km long and each line conductor has a reactance of 1 ohms per kilometer. And we assume R is equal to 0. And then determine the kVA supplied by the connector. So what happened? We have P here. So P, E and V is 152 kV. Okay. And we have our Z ataupun X because we assume our R is 0 is 1 ohm per kilometer. And our length is 100 km. So next, apa yang perlu buat ialah you kena darab lah. You darab, you akan dapat 1 ohm per kilometer darab 100 dapat J100 ohms per 300 ohms, meaning that the system is 100 ohms. Okay, so change into the magnitude, you dapat this value, and then apa yang you dapat, we know already our P, this is our P. Okay, SB PB minus plus JQB. So daripada sini you kena cari value Q lah. Using this equation kan, cos mana equation ni terabur dah. Kita kena cuba cari equation ni lah. UB EB bagi X cos theta. So yang tinggal adalah elements EV over X cos theta minus V square over Z over X. Kita masukkan value, dia akan dapat Q 10.5 MVAR, and then this is our V SB. So you dapat, this is the real power, this is in reactive power, and then ambil reactive from here you boleh tukar daripada magnitude and angle. So this is our 19 kVA lah. And then next you need to find your theta. Theta is 20 degree. Just rearrange this equation. Guna equation ni. Okay. I think that's all for today. So kita akan proceed with how we want to calculate sending and receiving power in terms of power, reactive power, and in next class. Ada soalan?
Tak ada, Doktor.
Tak ada.
Ya, so okay, saya dah upload dalam kalam soalan-soalan tutorial berkenaan dengan real power control ataupun low frequency control. So I hope you boleh buat lah. Boleh cuba buat. Kalau ada masalah boleh cuba. Saya ada bagi sekali dengan jawapan lah. So you cuba dapatkan lah jawapan lah. Serta soalan. Yang lain ada yang tak ada. So I think lebih kurang 24-25 soalan. Okay. So boleh cuba. Kita jumpa hari Khamis lah. Kalau tak sempat mungkin saya akan buat video. So saya akan buat asynchronous class. Saya akan bagi video untuk kelas seterusnya. Okay. So to wrap up, we have discussed about the ED, real power control. Now we move to the reactive power control. So basically reactive power control ni some part of the because when we talk about the reactive power control, we talk about the voltage control, sama je. So some part you dah belajar dekat EPS lah. Okay, so I think that's all for today. Thank you very much. Thank you for your attention. Assalamualaikum warahmatullahi taala wabarakatuh.
Terima kasih, Doktor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doctor.